For engineering services general studies video lectures, visit www.iesgeneralstudies.com. For mechanical engineering video lectures and question and answers discussion, visit www.gatmech.com.
We have seen already how to find determinant of a 2 by 2 matrix. Now actually what is the concept behind a determinant, definition of a determinant, that let us see. I'll take here one small 2D coordinate system. One 2D coordinate system where this is the positive x direction and this is positive y direction. Say suppose this is 1 unit, 2nd unit, 3rd unit and 4th unit. 1 unit, 2nd unit, 3rd unit and 4th unit. Okay, I'll take 4 points here. This is 0, 0, everybody knows it. This is 1, 0, the point corresponds to 1, 0 point at this one, and the point corresponds to 0 since x, there is no unit in x direction, only y direction 1 unit we have moved. Here also there is no unit in x direction, 1 unit we have moved to reach this point, and y direction nothing we have moved. So that's why it is 1, 0, and one direction in x direction and one movement in y direction. If you move, you will get the point 1, 1. So there are 4 points. Okay, the first one I'll write all the 4 points in terms of vectors here. The first one is 0, 0. The next one is 1, 0. This is the position vectors. Okay, the next one is 0, 1. The next one is 1, 1. These are the 4 position vectors I have taken here. Now I will consider a transformation matrix. I will call it T of magnitude 2 by 2, of size 2 by 2. Say suppose that is 2, 0, 0, 3. I am considering one transformation matrix T here. Okay, that is 2, 0, 0, 3. Now I will apply this matrix. I will find the product of T into the first position matrix. Say suppose this position matrix is O. Okay, I'll write it directly there. Okay, say suppose this point is O, this point is A, this point is B, this point is B, this point is C. Okay, the first position vector is 0, O. O is, its position vector is 0, 0. Second position vector is A. A is 1, 0. B is 0, 1. C is 1, 1. No, B is 1, 1. C is 0, 1. No problem. B is 1, 1. C is 0, 1. Correct, right? A 1, 0, B 1, 1 and C is 0, 1. Now I'll find out the multiplication of T into O. What would be the multiplication of T into O? 2, 0, 0, 3 into O is OO. If we find out the resultant, it will be 2 into 0 plus 0 into 0, it is 0. 0 into 0 plus 3 into 0, it is 0 again. Similarly, T into A, I will find out, that is 2, 0, 0, 3. This is, A is 1, 0. This is equal to 2 into 1 plus 0 into 0 is 2. 0 into 1 plus 3 into 0 is 0. 2, 0. And T into B, 2, 0, 0, 3 into B is 1, 1. 2 into 1 plus 0 into 1, 2. 0 into 1, 0 plus 3 into 1, 3. Then T into C. This is 2, 0, 0, 3 into C is 0, 1. So 2 into 0 plus 0 into 1, 0. 0 into 0 plus 3 into 1, 3. Okay, so if you can see, as I have already explained, multiplication is nothing but some kind of a transformation where by multiplying this particular O with T, it has been transformed and gave us a new coordinates. The same thing I locate here. All this transformed matrix this I will call it as O dash, this I will call it as A dash, this I will call it as B dash, this I will call it as C dash. This is the newer coordinates, whatever we have got. I will better write it with a different thing for us to differentiate between the old one and the new one. This is O dash, this is A dash, matrix A dash, this is position matrix or position vector B dash, this is position vector C dash. Now if we can identify the initial point during, this is nothing but a transformation, so the initial first point was 0 0. After multiplying with T, transformation matrix T, it became O dash. However, it did not change, so the new coordinates of 0 0, O point here, remained same, it is 0 0. Okay, now point A earlier was 1 0, it has been changed to 2 0. Now the new point A, I will call it as, this is, it has been 2 0 means 2 units in x direction, 0 units in y direction means this is the point. So the A became A dash and it is 2 0. Okay, now B earlier was 1 1, it became 2 3, B dash, B became B dash, it is 2 3. If you see 2 units in x direction, 3 units in y direction, 2 units and 3 units in y direction, 1 2 3. 1 2 3, 2 units in x direction, 3 units in y direction. Okay, this became the new B dash, that coordinates are 2 3. The C earlier was 1 0 1, now it became 0 3, C dash. So earlier was 0 1, it became 0, x direction 0 units, y direction 3 units, 1 2 3. So this is the new C dash, the coordinates are being 0 3. If you observe carefully, you can find the meaning of the determinant here. Okay, if you see using O, A, B, C points, if you can find, if you can get a form an area or a rectangular, the area covered between these points earlier was how much? Area covered, area is equal to width into height. What is the width here? 1 unit into 1 unit. This is 1 into 1. So 1 square unit it is. You can consider it as mm or centimeters or meters, kilometers, whatever it is. For a time being, I am considering it as 1 square unit. So using the old 4 points, earlier 4 points, the area that we could cover is, the area that is formed is 1 square units. Now using the new 4 points, the transformed points, what was the area? The transformed points formed this square, correct, right? This rectangle. What is the area of this? Width into height. What is the width? So the new area, I will call new area post transformation. I will write post transformation. Transformation here is meaning multiplication with the transformation matrix T. So the new area is equal to 2 width 2 units into height. How many units? 3 units. So that is 2 into 3, that is 6 square units. If you can see here, because of multiplication, because of transformation with respect to this using this matrix, the area of 1 square unit has been changed to 6 square units. What is the scaling factor here? The area scaling factor. So here the scaling factor is 6 square unit. Later, initially it was 1, so 6 by 1, that is equal to 6. The scaling factor is actually 6. Okay, we know already how to find the determinant. Now you find the determinant of this T matrix. Okay, what is the determinant of this T matrix? Det 2 0 0 3. It would be AD minus BC. So 2 into 3 minus 0 into 0. This is nothing but 6 minus 0. This is equal to 6. So the determinant here equals the scaling factor here. This is what is the significance of a matrix. Determinant of a matrix. What is the significance? It tells you if you perform any transformation using that matrix, it gives you by what amount the corresponding, if it is a 2D space, by what amount the corresponding area would get scaled. would get scaled up. This is what the determinant gives you, the scale by which the area will get scaled. For example, in terms of a 3D space, say suppose one cube was formed using some 8 points. This is a cube earlier. Say suppose initial volume was V1, all points are 0, A, B, C, all points are there. You have applied again transformation T, means you have multiplied with T with each points. Again, after multiplication, each point has been again transformed into a new point. You again connect all those points and find out the cube. Say suppose the cube has been formed something like this. Okay, say suppose this is something like this. So in the black whatever is there, the original cube, post transformation with this matrix, post multiplication of T is the transformation matrix with all the corner points, then you have found the cube has been transformed like a new cube. Now say suppose that volume is V2, the new volume is, say suppose it is V2. The first volume is, initially before the transformation the volume is V1, post transformation the volume is V2. Now the determinant of this matrix would be equal to, the determinant of the matrix T would be equal to V2 by V1. It will give you the ratio of the volumes, change in volumes of that particular cube. This is an example in 3D space. This is an example in 2D space. Similarly, here also area, if you find any planar area, it would get scaled post transformation with respect to that using this using the corresponding matrix. How much our amount it would get scaled, that amount would be given by the determinant. This is the significance of the determinant.
For engineering services general studies video lectures, visit www.iesgeneralstudies.com. For mechanical engineering video lectures and question and answer discussion, visit www.getnet.com.